Hi everyone, we're going to start section 5.2 on verifying trig identities. Now this is both harder and easier than section 5.1 on simplifying trig expressions. It's harder in the sense that we tend to deal with more complicated expressions in these problems. It's easier in this following sense. We're basically simplifying. Like for example here, we're going to simplify from the left side to the right side. But this time, unlike in 5.1, I'm giving you the answer. So in that sense, 5.2 is easier, but we're dealing with more complicated expressions. So it's a bit of both. All right, let's verify this identity. I claim that this statement holds for all real values of theta as long as we don't have a domain problem. And in section 5.2, we're going to sweep domain issues under the rug, pretty much. All right. Now, in these verification problems, you need to choose which side to start from, the left-hand side or the right-hand side. And then, starting at one side, you're going to proceed and simplify that side until you obtain the other side, verbatim, exactly as it is. Many students like to do a little bit of work on both sides. That's okay to help prepare yourself, but in the end, you really should start at one side and indicate which side you start at. Maybe by typing in something like, or writing in something like LHS for left-hand side, or RHS for right-hand side. Usually we start with the longer, more involved expression and then trash compact it down to the smaller, more compact expression. Although that's not always the case. I would say, though, that if you try to blow up the right-hand side to match the left-hand side, you might have to be more creative. But in this problem here, we're going to start at the left-hand side and try to obtain the right-hand side verbatim. I'm going to think of this as the target. It's a target that we're aiming for. Imagine the top of a jigsaw puzzle box. We're aiming for that target. And keep that in mind. Now, I present to you 4 solutions to verifying this identity. Actually, it took me 4 tries to get me my best solution, which is not even in my notes. I'm going to show you my 4th and best solution now. Now, bear in mind, on your homework, on exams, you may not have to give the absolute best solution from the book. This is often referred to as kind of God's book, where all the best proofs and solutions are. You don't have to give me the perfect solution here, but try to avoid giving me something that's 10 pages long when 4 lines would do. It turns out that it took me 4 tries to get me my best solution, and I'll show it to you now. Now, with all 4 of my solutions, I start with the left-hand side. It's the longer, larger, more complicated side. We normally do go from the larger expression to the smaller expression. Though not always. Sometimes we do go smaller to larger, but usually we go larger to smaller as a strategy. All right. Now, a key strategy, which I came up with kind of down the line, internal consistency. Now, what do I mean by this? We often help ourselves by making these pieces look like each other. In my first attempt at attacking this problem, I did what a lot of students did. I broke this down into sine of theta and cosine of theta, and I'll show you the result of that soon enough. But it turns out that my much more efficient strategy over here appeals to the idea of internal consistency. Make these pieces look like each other. And by the way, target the target. Aim for the target. That's another strategy. Aim for the target. And keep that in mind. We want to aim for the target. So in my solution number 4 here, I indicate that I start with the left-hand side. You should either copy the left-hand side outright or just write LHS to clearly indicate which side you're starting at. Now here's my strategy in my solution 4, my best solution, I think. My strategy here is to make these pieces look like each other. Now, a lot of students would be inclined to make cosecant of theta look like sine of theta, and to make cotangent of theta look like tangent of theta. cosecant of theta is 1 over sine of theta, for example. But remember that we want to aim for the target. We want to aim for cotangent of theta times cosecant of theta. Instead of making the top pieces look like the bottom pieces, it may be more strategic to make the bottom pieces look like the top pieces. Again, we can use reciprocal identities. But this time, we're going to use the fact that sine of theta is the reciprocal of cosecant of theta, over here. And in the bottom left, tangent of theta is the reciprocal of cotangent of theta. So this might look a bit strange, because you may be used to expressing bigger trig expressions in terms of what you think of as easier or nicer trig expressions. We may be more familiar with sine of theta and tangent of theta than these two guys up here. But remember, we also want to aim for the target. In the end, we want to end up with cotangent of theta times cosecant of theta. So it may be better for us to make the bottom guys look like the top guys, which I do here. All right. So now we have a compound expression. We need to make this a lot simpler. Well, there are different strategies. Some students might want to get a common denominator for these two fractions down here and make this bottom denominator, this denominator here, into a single fraction. That's totally legal. Maybe multiply this by cosecant of theta over cosecant of theta, and multiply this fraction by cotangent of theta over cotangent of theta. That would work. In my document here, I try a different strategy. I take the overall LCD, which is the product, really the LCM, the least common multiple, of these little denominators over here, cotangent of theta and cosecant of theta. They don't really have anything good in common. They don't have much in common besides plus or minus 1. So I'll take their product as the overall LCD. And I'm going to multiply the top and the bottom by this LCD, this overall LCD, the product of these two little denominators. My goal is to ultimately clear these fractions down here. So I'm going to multiply this fraction by 1. Again, don't worry about domain issues right now. I'm going to multiply by 1 in the form cotangent of theta times cosecant of theta times itself. The goal being for this product down here, when it distributes through, I'm going to clear the fractions down here. Now in the top, you might be tempted to distribute in the top. Many students like to apply the distributive property because they like to show off. They like to show off what they know. But it turns out that distributing up on top will just waste your time. You're going to have to factor back like this anyway. So don't distribute just because you feel like it. On the top, we're not going to distribute cotangent of theta, cosecant of theta into these two terms. You're just going to make a mess, and you're going to have to factor back later on. We like factored forms. We like factored forms, provided that the pieces are fairly nice. Down here, when you look at these denominators, look at this denominator of this compound fraction. We don't like the fact that we have these fractions inside the denominator. That's why we have a compound fraction over here. So I actually do want to apply the distributive property and distribute cotangent of theta, cosecant of theta into these two terms here. I want to distribute. Because multiplication distributes over addition, I'm going to hit both of these terms by these two factors, cotangent of theta times cosecant of theta. The goal being to kill the denominators down here, the little denominators, and to avoid a compound fraction after this point. So again, do not distribute on the top because we like factored forms when the pieces are nice, but we are going to distribute in the bottom because I don't like these fractions here. I don't like these little denominators. So let's clear them. All right. Again, on the top, I'm going to multiply them, but I'm just going to indicate them in factored form. The factor, cosecant of theta plus cotangent of theta, okay, times this thing we're multiplying by, cotangent of theta, cosecant of theta. I'm going to indicate this product, but I'm not going to distribute because that'll be a waste of time. If we distribute, we'll just make a mess of things, and we're going to end up having to factor back anyway. Remember, we like factored forms because we're hoping to cancel later on. Factors up here with factors down here, eventually. but we have to clean this bottom guy up. Okay, we do want to distribute these two factors to these two terms over here. Now, you can actually skip this step here. You can skip this step here if you do the following step, but I will show you this step here to clarify what's going on. And some students might need to do this, especially as they're still learning things or reviewing things. How to work with rational expressions in trig functions, in this case. Now, when we multiply the bottom of this fraction by cotangent of theta, cosecant of theta, what happens? This fraction, 1 over cotangent of theta, gets hit by cotangent of theta, cosecant of theta, plus sign, this carries over. This fraction, 1 over cosecant of theta, 1 over cosecant of theta, also gets multiplied by cotangent of theta, cosecant of theta. Now what happens? We get some cancellations. Cotangent of theta divided by cotangent of theta, in red here, these divide out to 1. I should put little ones here, but I'm trying to make things fast. Here, cosecant of theta divided by cosecant of theta is 1. These red pieces basically die out. So then in the bottom, we're left with cosecant of theta plus cotangent of theta. Now again, with time and practice, you may be able to figure that out right from this step here without having to do this step here. So if you do that, great. When you multiply this fraction by all this, the cotangent of thetas die out, they kill each other off, cosecant of theta remains. When this fraction gets hit by cotangent of theta, cosecant of theta, the cosecant of theta pieces die, and cotangent of theta remains. So whether you write it all out or you do it more mentally, we end up with this. So we have that product up on top, and we're just left with cosecant of theta plus cotangent of theta down below. And do you see what happens? Do you see what happens? Cosecant of theta plus cotangent of theta is a factor of the entire top. Cosecant of theta plus cotangent of theta is a factor of, in fact, it is the entire denominator. This divided by this is 1. Again, don't worry about hidden restrictions or anything like that. Sorry, I redlined the wrong piece. That stays in black. This piece here goes red. Okay. So cosecant of theta plus cotangent of theta, it's a factor of the entire top and the entire bottom. These divide out to 1s. I should put 1s to indicate what's left. Okay. I don't like saying that a denominator just disappears. So we're left with, lo and behold, whoops, we're left with cotangent of theta times cosecant of theta. We're left with this expression in black, cotangent of theta times cosecant of theta. Hey, we hit our target. By the way, if you had switched these, if you had had cosecant of theta, cotangent of theta, then you would have needed one more step. You would have had to switch these factors. Remember, we do want to hit the target, the right-hand side, verbatim, exactly. So your final expression here really needs to match exactly the final expression over here. Give or take parentheses. I know that nowadays I like to put parentheses around the thetas, but don't freak out about that. This is basically verbatim with respect to that. They're copies. So we're done. We've shown that, again, we're not worried about domain issues or hidden restrictions right now. We've shown that the original left-hand side, way up here, is equivalent to this after several steps. And you do have to show basically all these steps, except in the distribution, you can skip from here to here without having to show all of this in gray here. But remember, when you show your steps, you do have to indicate every time you apply a trig identity, for example, showing that tangent of theta is 1 over cotangent of theta. You can do a couple of them at the same time. You can do more than one at the same time, as long as you're working on completely different pieces. Don't do too much blending. Don't do two things on the same part of the expression at the same time. In principle, you could break up more than two of these expressions working on this, working on this, working on this, and or working on this, provided that you know your places so that you're not doing too much blending or doing more than one thing at once to one part of the expression. But I can show that tangent of theta is the reciprocal of cotangent of theta, and sine of theta is the reciprocal of cosecant of theta in one step. That's okay, because I'm not doing more than one thing on the same piece of the expression. And then when you do a key algebra step, in this case, we're multiplying top and bottom by the overall LCD, then show that. Or show how you're building up these denominators to get a common denominator. Some students may prefer that. Again, you can skip this step if you show this step over here. Show that these two cancel. They divide out to 1. And make sure you get your final expression verbatim. All right. I think that is the best solution. It may be the solution in the book. And then I'll show you my runners-up, my first 3 ways of approaching this. And I think there's a lot to be learned when you stumble along. So I'll show you my 3 other solutions in the notes in the next video.